Hello and welcome to SGN Tech Forum. In this module or in this video, we are going to talk about second layer of OSI module, which is data link layer, and the protocol which is predominantly used in this layer is Ethernet. There are other protocol also like SDLC or PPP, but we are going to discuss about Ethernet and take a deep dive into frame structure or what are the different component of a Ethernet frame. So on layer 3 it is called packet, but on layer 2 we call it frame. So obviously this is second part of data link layer, which is layer second layer of OSI model, and Ethernet frame must be at least 64 byte. Minimum size should be 64 byte, and it can be maximum about 15-18, and nowadays some network element support jumbo frame which can push it like 9000 plus bytes. So on my screen you can see this is a typical Ethernet header look like, and now we are going to discuss about each and every field within the Ethernet frame and why they are important. And so it will help you understand how data is transferred within layer 2. At layer 2 there is another concept called VLANs. So if you are a network engineer, you must be familiar with VLAN, which is like segregating your broadcast domain. So a VLAN is nothing but a additional 4 byte fields which is inserted in between this Ethernet frame. So VLAN is 802.1q IEEE standard specification, and it is two 2-byte field, that means 4-byte field, which is inserted just before the type field. So Ethernet frames add tag field before type field to accommodate the VLAN tags. And what is the VLAN tag? Let's take a quick look at VLAN tag, and then we'll come back to the Ethernet thing. So two bytes. The first 2 bytes are called TPID, and second 2 bytes called TCIE. First 2 byte is actually fixed, and it is assigned a value of hexadecimal value of 0 cross 8100. So TPID is fixed. TCI field, they are broken into 3 fields. So you have PRI, which is your class of service, which is used for layer 2 QoS, and then you have 1 bit of CFI. CFI is a legacy thing which is used to differentiate between Ethernet and token ring, but it is not used anymore. And then 12 byte of VLAN ID or the VLAN tag. So VLAN ID is 12 byte. That means you are restricted to 2 to the power 12, which is 4K VLANs. You can have maximum 4K VLAN per segment. Now let's go back to Ethernet field and understand how Ethernet field, what are the different Ethernet field and how the frames are transferred. So let's take a deep dive into Ethernet frame. So the first thing what you can see is a preamble and SFD, which is start of the bit. So the first preamble is 7 byte. Out of this 8 byte, the first 7 byte is all 101010. So they are sequence of 101010, and then you have start of frame, which is actually 1 byte, but it reads like 101010 and then 11, so that receiver know that this is the start of the field. So initially it was the preamble, which is used for clock synchronization. So receiver and sender, they can synchronize their clock, which is very important. And then you have SFD bit. As soon as receiver sees 1 instead of 10, it recognizes that this is the start of field, and then it should expect the other fields like the destination address. So destination address is a 6 byte or 6 octet field, which is set to your burn-in MAC address. So your Ethernet NIC card, they have a vendor specification NIC, and it has a hard-coded MAC address on that. So that is your destination MAC for the receiver, and source MAC is the similar MAC address from the sender. Ether type field in Ethernet 2 frame, ether type field is always fixed. It is 2 byte long and it is fixed today to 0 cross hexadecimal 08800. Then you can have additional or optional 802.1q tag, which we discussed earlier. So if you have VLAN tag present, then you can expect a tag field here just before the type, which is your VLAN encapsulation. Then you have FCS. FCS is just like other upper layer protocols. FCS is used for header checksum, and it detect if the data is corrupted or data is safe. Then you have the payload, so which is the actual data. Minimum payload is 42 octet, and if the VLAN tag is present, then it is 46. The maximum payload is 1500, but as I mentioned initially, now with VXLAN and other technology, all the network equipment, they started supporting jumbo frame, which is greater than 9000 bytes. Then you have inter-packet gap. Inter-packet gap is very important. This is the ideal time between two frames. So which is 96 bit of ideal line state. So it depends how many seconds it will take to transmit 96 bit, depend on your network speed. If you are using 1 gigi or 10 gigi, so you can calculate how much time it will take to transmit that 96 bit. But this 96 bit is very important because it actually differentiate between two frames, two Ethernet frames. So receiver knows that, okay, this is after elapsing of this ideal time, now I should start looking for Preamble, which is a sequence of 101010. So that is how the Ethernet frame travels through the data link layer. And so I'm not going to present any demo in this video. Next video we'll be doing address resolution protocol, which is again data link layer protocol, and in that video I'll show you how Ethernet find out the destination MAC address, and I'll walk you through the Ethernet packet cap frames in that video. Thank you for watching.